Good morning. Today we are going to begin a short group of presentations about climate change, biodiversity loss, land use change, and their global and local effects, particularly in the Amazon basin. We are going to concentrate not only on the effects, the particular effects of climate change, but also on the interaction among these global environmental problems, the potential adverse impacts on the Earth system as a whole, and particularly on the rainforests in the Amazon basin. At the same time, we are going to present the need to expand current mitigation policies on climate change, including the idea of keeping fossil fuels underground, particularly in biodiverse hotspots in developing countries. In this presentation, the first of them, we are going to analyze some basic traits about climate change. First, we would like to begin with a specific analysis about global natural disasters taken from the UN database in the last half a century, approximately between 1970 and 2021. We can see two kinds of global natural disasters. The first kind, which is presented in the lower part of the chart, it refers mostly to geological natural disasters, mostly earthquakes and volcanic eruptions. We can see that they are obviously aleatory, but the number of the incidents of these events are more or less constant in the last 15 years. Conversely, natural disasters linked to climate, particularly floods, storms, landslides, wildfires, and so on, have been dramatically increasing in the last 50 years. You can see, for example, that in 1970, the total number of disasters in the planet was about 75. And in the last year of the record, 2021, the number went to over 400. That means we have about a five-fold increase in the risk of global natural disasters. As a result, climate is becoming unpredictable, and the adverse effects of climatic events on living conditions of the planet are increasing. This is one of the results of the recent anthropogenic climate change, which is taking place mostly from the Industrial Revolution onwards. The basic idea of climate change is linked to the role of the troposphere, of the atmosphere in regulated climate. Climate in the planet is mostly the result of the balance between the energy that the planet receives from the sun, mostly in form of visible light, and the energy that the Earth sent back to space. when we have an equilibrium between the energy coming from the sun to the earth and the energy returned to space from the planet, the climatic conditions are stable. But actually, the troposphere, the lower part of the atmosphere, have a role because in the atmosphere we have some gases, particularly carbon dioxide, nitrous oxide, and methane, that have the capacity to trap part of the energy that the Earth is sending back to the space, producing an increase in temperature of the planet. The problem is that the concentration of these greenhouse gases went up dramatically since the Industrial Revolution in the last 250 or 300 years. Here we have a clear example with the most important greenhouse gas, which is carbon dioxide. We can see here the concentration of carbon dioxide in the atmosphere in the last millennium. So we can clearly see that this concentration, which was about 280 parts per million in the last centuries, before the Industrial Revolution, was about a constant. Nevertheless, when the Industrial Revolution began, we began at the same time burning fossil fuels, mostly coal, oil, and later natural gas. As a result, concentration of carbon dioxide went up dramatically, and in the last point in the record of this year is above 417 parts per million. So what we have is, as we can see here, we can observe emissions of carbon dioxide, mostly from fossil fuel combustion, which is in gray, coming from deforestation, which are also very, very significant. Here we can see land use change that went to the atmosphere. The Earth system is able to track, to return to the Earth part of these emissions with carbon sinks. The most important one is the ocean, and the second one are the forests. But the part of the emissions that is not taken from the ocean or the forests, or the vegetation in general, is remaining trapped in the atmosphere. That is why the concentrations of greenhouse gas in the atmosphere are going up on. The problem is essentially that in spite of some international agreements, such as the Kyoto Protocol, or the most recent Paris Agreement, we have not been able, as a humankind, to stop this dramatic increase in greenhouse gases concentration in the atmosphere. Here we can see the time series linked with the carbon dioxide, which is going up, and the line is not changing in the last years. We cover here the period between 1958 and present, and we can see the same, more or less the same, both with methane and with nitrous oxide, which are the three most important greenhouse gases. So the effects of mitigation policies to try to avoid or reduce climate change so far have not been sufficient, has not been enough to present an important change in the increasing trends of greenhouse gas concentrations. Here we can see the effects. Here in this chart, we have average Earth's temperatures from 1950 to present. No, from 1880 to present in the more than 100 years in the time series. And we can see particularly after 1980, a huge increase in temperature that has not been controlled. As a result of that, current planet temperatures are about 1 centigrade degrees over the average. The problem with the Earth is that we are not only affected by this specific problem, a global environmental problem such as climate change, but at the same time we are suffering from other global environmental problems, particularly biodiversity loss, land use change, and the pollution generated by biochemical flows linked mostly with fertilizers, linked with phosphorus and nitrogen. The planetary boundaries are essentially the limits of the regenerative capacity of the planet to neutralize the impact of human activity. Unfortunately, human impacts of the planet have been growing so much that it's extremely difficult to keep the stable conditions that prevailed during the current geological period, which is the Holocene. Here we have a map presenting the primary forest coverage in the largest remaining rainforest in the planet, which is the Amazon basin. In reddish colors, we can see the impacts of the tree cover loss in the current century. Unfortunately, the Amazon basin already have lost about 14% of the original rainforest coverage, and an additional 17% is affected by forest degradation. So the result is extremely difficult for the Amazon as a whole. The problem is that if this process is going to continue in the future, we are going to increase the risk of a tipping point, a point in which the cumulative effects of deforestation and climate change can reduce humidity in rainforests to such a level in which a self-feeded process of destruction of the rainforest is going to be unleashed. And the Amazon can begin a process of savanization, a conversion basically to a kind of grassland, which might have huge impacts in the future of the planet. Here we have the evolution during the last 600 million years of the number of families, which is an important indicator of biodiversity, beginning with the Cambrian period in which life began to evolve very quickly on the continents. That's very interesting. We have a dramatic increase in biodiversity, but at the same time, as the chart shows, we have several events of mass extinction. We recorded 5 of them from the natural history of the planet, but as a result of recent human activity, we are generating the 6th global mass extinction. And so the planet is not jeopardized only by climate change, but also by biodiversity loss in such a way that has never seen in the past. In essence, we can reach some basic conclusion. First, fossil fuels combustion and deforestation have led to climate change, jeopardizing the achievements of the social and economic achievements, the transformation originated in the Industrial Revolution. The complex interaction amongst climate change, biodiversity loss, and other global environmental problems poses a serious risk to modern human society. So far, climate change mitigation has not been enough to counteract, to balance the unprecedented rise in greenhouse gases concentrations in the atmosphere. So the problem is far to be solved or limited in an effective way.